the studio by Professor Ed Maginn from the College of Engineering. Dr. Maginn is the Dreamin Family Professor of Energy Studies and Department Chair of the Chemical and Biomolecular Engineering Department. Dr. Maginn, welcome to Notre Dame Day. Thanks so much for being here.
Oh, it's a pleasure to be here this morning.
And I'm so pleased with myself that I can pronounce all of the words involved with your title. So tell us a little bit about the very complicated work that you do.
Well, in chemical engineering, we work on kind of molecular scale phenomenon that try to bring together some of the aspects of biology and chemistry and physics and combine that with engineering principles to design new devices, processes, materials in a whole wide array of different fields and different industries.
So clearly very important work. Where are you from originally?
So I'm originally from Des Moines, Iowa. I went to Dowling Catholic High School. So of course I knew all about Notre Dame, but I didn't go to Notre Dame as an undergraduate. I went to Iowa State, worked for Procter & Gamble for a while, and I went out to UC Berkeley, did my PhD, and found out that there was a job opening on the faculty at Notre Dame. I was fortunate enough to get the position, and I've been here for 20 years now.
So you've gotten over the California dreaming at least, and now you're grounded back in the Midwest.
I'm fully used to the snow and lake effect snow.
Lake effect snow, the words I never wanted to hear again after I graduated.
No, I bet, yeah.
Well, tell us a little bit about what biomolecular engineering is, what you do.
So if you think about all the kind of aspects of society that deal with energy, with the environment, with healthcare, pharmaceuticals, all of those really involve kind of molecular scale phenomena that we understand and try to study as chemical engineers, and then we try to develop solutions to some of the pressing problems in those areas. So for example, in the area of energy, and we've all heard about the fact that we have a lot of problems with fossil fuels, global warming. How do we more efficiently use those energy resources? And then how do we develop new technologies that can get us beyond sort of our traditional fossil fuel energy base into renewables? So for example, we have people in the department working on developing new photovoltaic materials so we can do solar energy. We have people working on more energy efficient processes. All these things we're kind of bringing to bear to try to solve some of these pressing problems in energy. We also work in the areas of healthcare, trying to develop medical diagnostic devices that can treat human disease, detect disease before, say, cancer becomes a problem. In the environment, if you think about LA, 30 years ago, the smog that was in LA, now the development of catalytic converters, which was really developed by chemical engineers. Some of my colleagues, Bill Schneider, for example, was involved in developing new catalysts that can clean up the exhaust of cars. Now we have clean skies over LA as a result of what chemical engineers do.
That must be incredibly rewarding to know that the work you're doing can contribute to the future in the way that it does.
It is, and it's really, I think, what's motivated the fact that we have so many undergraduates now in our program. Chemical engineering is one of the largest majors on campus now. We have almost 100 graduates each year in our program. And it's really exciting for me to work with the young people. The Notre Dame students are so impassioned about wanting to help the environment, to really make a difference in people's lives. And I think that they see that through a chemical engineering degree, they really can do that.
It certainly opens a lot of doors and offers a great deal of opportunity. You mentioned solar energy. Is there any one project in particular that you're really excited about right now?
Yeah, Professor Prashant Kamat, who works on a material called a perovskite type material. These are very simple materials that have been known for a long time. And what his lab has been able to show is that you can get incredibly high efficiency. So converting solar energy into electricity, the conventional technologies, that's not very efficient. And Professor Kamat's lab has been able to demonstrate really high efficiencies in these perovskite type materials. They're cheap, earth-abundant materials. And I think it's really could be a game changer in making solar energy a real viable commercial reality.
That is very exciting. It'll be great to see what happens next. Dr. Maginn, thank you so much for joining us early this morning. We appreciate your time.
It's my pleasure. Thank you for having me.